Well, thank you guys for showing up on Friday. I guess it's not 9 a.m., right? I'm wondering if people actually showed up at Phil's talk this morning at 9. If you guys were anything like me, certainly I had the nice thumping bass thing happening until about 3 a.m. last night. So I have a problem that I want you guys to help me with. And the problem is that, these dynamic languages, right, that I'm so fond of, right? As you can see by the massive attendance in this room, not everybody is as fond of dynamic languages as I am. And I certainly have, this thing that I'd like to do, which is to try to get, more people to use Python and Ruby out there in the world, certainly the two languages my team builds. But of course, it's a hard thing, right? And I would imagine that it's probably almost about as hard as what these guys are trying to do. So I just saw this last night, right, through the miracle of social networks. Apparently, there's all these guys out there that are trying to get Star Trek captain's chairs installed in their living rooms. And, so there's actually a whole bunch of these guys, right, that are doing exactly this, and some with more or less success with their wives getting these chairs put in their living rooms. And so what I was thinking is, it's kind of a similar thing, right? You're trying to say, well, I'm suspecting that, the folks in this room rather like dynamic languages, or at least I hope so. And, so you're facing a challenge of convincing your spouse that you need to have one of these things in your living room. Now, I think that we can do this. But it's really not about kind of getting rid of all of the furniture, right, in your house and just having the captain's chair. But in a lot of ways, it's really trying to, take what is useful about the captain's chair and trying to integrate it in with the other things that you already have. Now, dynamic languages are in a lot of ways like that, right? Because what I'm trying to get folks to do is to use these things, but in order to use them, how are you going to use them, right? Are you going to, all of a sudden have a brand new project that you're going to create, and from this brand new project that you've created, you're going to go off and create the awesome Python or Ruby app? Well, for some people, that's a wonderful thing that they can do, right? But for the vast majority of people, that's not the case, right? You've got some code base out there already that you would like to continue to build, and you've already built big chunks of it in whatever your favorite language was up until now. And of course, since this is Mix, and I have to talk about Silverlight, I'm going to assume, that you've gone off and built some Silverlight code already using your favorite static language of choice. So what I'm going to talk about here is how we can go off and use dynamic languages to make your existing Silverlight applications better, right? And there's two kind of approaches that I want to take in this talk. One approach is looking at, oh, wow, people are going to send me messages like this. Awesome. Okay. I need to turn that off. But goodbye. I don't even know that guy. So what I'd like to do is take these two tacks, right? The first tack is, how can you use a dynamic language to test an existing Silverlight application that you've already written in C#, right? And what we'll do is we'll look at some of these, behavior-driven development style unit testing frameworks that you can use simultaneously in the browser to go off and poke at your Silverlight applications. The first kind of approach it will take. Second approach, which also makes sense, is to look at how we can take your existing application and extend its functionality using scripting code, right? So certainly you've got your compiled app. You'd like your users to go off and add additional functionality to that application without requiring that user to have your build environment present on their machine, right? So that's another really good thing, and we'll take a look at that, both in the context of the same application. The third thing I'm going to talk about, well, I said two, I lied, there's three. The third thing I'm going to talk about is how we're going to take ASP.MVC and look at some of the interesting ways that we can integrate Ruby into the MVC framework on the server with, an eye towards, ultimately generating some Silverlight code that goes down to the client as well, right? So we're going to take a look at all three of those things today. So that's kind of the meat of the talk right in the middle, those three scenarios. I'm going to start off by kind of looking back at where we came from and where we are today and where we're going. And we're also going to spend some time after those demos looking at optimizations. Like certainly Silverlight 3 gives us a whole bunch of interesting opportunities to do some optimizations. Optimizations around download sizes, startup time, and as well as a startup performance, right? Those are some of the things we're going to take a look at. Because certainly you might be paying certain penalties there, right? You really want that great instant activation experience of your application, right? So we'll look at some of the things we can do to make that happen as well. And then finally, there's this little, plea that all guys that run open source projects do, which is, what you guys can do to help me or help us. So this is a little timeline that kind of looks at, where we came from. Way back in the beginning of time at MIX09 was when, we first did the announcement of the DLR piece. So Jim and I came here to give a talk about the launch of the DLR. And really the DLR was a piece of software that grew out of IronPython initially, right? Right after IronPython shipped, it was both easier and harder than it should have been to go off and implement our Python language on top of the CLR. So after that was done, we decided to factor out the common pieces from Python, a lot of the runtime pieces, a lot of the things that deal with .NET Interop, the binder code. That stuff is factored out into this piece of software called the DLR, and in order to prove that that subset of Python, that runtime subset, was portable across languages, we decided to implement 4 different languages. Right, so we went off and there was Python, there was Ruby, there was a JavaScript implementation, as well as a VB implementation. So across those 4 dynamic languages, we felt that we had a reasonable survey of languages, to at least prove to ourselves that this was a reasonable thing for us to do. And that timeline kind of shows, some of the progress that we've made since we did that. Of course, what happened was, the DLR was the Python language runtime when it started out. Right, so there were a lot of design changes that happened over the past couple of years, really to certainly accommodate Ruby, right? Because Ruby is the one that we work the closest with. The VB experiment was discontinued, and as was the managed JavaScript implementation. So really, those are the 2 languages ultimately that drove a lot of the design into the DLR. And those are just some of the interesting little timelines and stuff, or milestones that we achieved. Now, one of the things that's different between the stuff on the bottom and the stuff on the top is that the stuff on the top has really gone more in a true open sourcey kind of a way. IronPython, while it is an open source project in the sense of the license, right, it's released under the Microsoft public license or permissive license. That license is certainly allows you to fork the code and go off and do with it as you will. Right, you can turn around and sell it if you wanted to, but what we haven't done there is taken contributions back from the community, right, inside of the Python code base. And that turned out to be good and bad for a number of reasons. But on the Ruby side of the house, we've done the opposite, right, which is certainly everywhere where we think it's reasonable for us to get contributions, and right now the reasonable part was in the libraries. We've accepted quite a number of user contributions to help us, get across to the finish line. So where we were last year was here, right? That percentage is the percentage of community-produced tests or specs, as they're called, that we were passing last year. And what's been happening is that in the intervening year, not only have we improved the percentage pass, but there have been a lot more specs written by the community at the same time. So this is where we are today. At least with Iron Ruby. So with Iron Ruby, we are 98% done, according to the tests, on the core language pieces. And we're 75 and 78% done in the built-in types, the things that you don't need to require in Ruby. And the standard library is 78%, which is the stuff that you have to require in. What that means in reality is we can run some of the more popular frameworks. I'm doing run in quotation marks. By running, we can certainly go off and start up Rails. We can run simple Rails applications, but that really hasn't been the focus of what we've been doing, right? Because essentially all it takes is for you to hit one of these unimplemented things, right, before things grind to a halt. Our focus certainly for Mix this time around was to finish our .NET Interop pieces. Right, so the key things that we're able to do now, which we weren't able to do, say, 3 months ago, was being able to go off and take a Ruby class and derive from an existing C# class, right? Override virtuals and the kinds of things that you would expect to be able to do, right? So a lot of the fit and finish in the .NET Interop pieces were the things that we really strove to get here, so we can do the Silverlight stuff for this conference. So that's a little bit about where we're at. Now, where are we going? We're projecting forward that we should be able to declare victory, at least in Iron Ruby, in around June of this year, right? June to July. We're really thinking that OSCON would probably be a good place to to declare victory, right, to do our 1.0 dance. Python, Iron Python is going to release a 2.6 build in 3Q09. Now, if you know our numbering scheme, that's a big jump, but that's simply because we're trying to sync back up with the C Python version numbers as well. So Python has already gone through 3 real releases already, right? You know, and Ruby is, Iron Ruby is hitting towards its first. So let's kind of look at some of the scenarios that I wanted to talk about. And really what we're going to look at first is the testing scenario. And in the testing scenario, how many people here have looked at the Ruby style behavior-driven development unit testing frameworks? Awesome. Oh, 1 guy, 2 guys. So what we're going to do is we're going to take a quick peek at the expressiveness of the language, right? Because certainly, you know, Ruby, you know, as a language has certainly been, you know, one of its strong points is being able to go off and build these domain-specific languages, right? And DSLs are certainly a term that's been horribly abused. I cringe almost when I say DSL. I really call modern API design, right? Because really, if you understand what Ruby is, everything in Ruby is a method call, virtually, right? There's only maybe 2 or 3 operators inside the actual language itself. Everything else is a method call. So really what we're doing is we're kind of doing interesting API design inside of Ruby. So what I thought I'd do is just go off and show you a little bit about what this one particular unit testing framework can do. This one's called Bacon. Right? Now, Bacon's an interesting framework because it's entirely self-contained in one file. Right? Certainly, as we've kind of looked at a lot of these things have kind of grown and become enormous. Right? There's been this interesting thing that's happened in the Ruby community where there's a bit of a throwback to simplicity. Right? You know, in contrast to a lot of the frameworks that we're used to using these days, it's rather refreshing when you can look at a unit testing framework and it fits in one file. Right? Or you can look at a web server. You know, Sinatra is another web server I've spent a bunch of time with in Ruby land, and it's a web server which allows you to build effectively, you know, controller. Really, it's a very simple MVC framework, but again, it also fits inside of a single file. Right? So as you might imagine, there's not an awful lot of features in it, but it's also easy to get the simple things done at the same time. So all we have to do is require Bacon. I always like typing that. So that goes off and brings the Bacon library into scope. And we can go off and just describe some operations that are math operations. So if you've looked at Ruby before, that might not quite look like Ruby, right? But as it turns out, that actually is just Ruby code there. What we're doing is we're invoking a method called describe. That is a top-level method. We're passing a parameter called math to that thing. And then between the do and the end thing is a second parameter, which is a block that's being passed to that function, right? You can think about that as a delegate or, you know, anonymous method. So that's what we're doing there. So I'm going to describe math, and then I can say it knows how to add. So I'm now going to invoke another method within that called it, right? Pass in this string, and there's another block where I'm going to go off and describe some operations that I want to do. Now, let's do something simple like, oh, I don't know, 1 + 1 dot should dot equal 2. Something like that, right? So again, some other interesting things about Ruby here is that everything in Ruby is an object, right? So the result of 1 + 1 is another integer, which is an object. What the Bacon framework does is it adds a method called should to the class object, right? So that appears everywhere on every single object inside of Ruby. So I have a should method, and I have another equal method that's tacked on. So should returns another object. That object, you know, implements an equal method, right? That should object essentially remembers what the left-hand side is and compares it against the right-hand side, which is passed in as a parameter. And if they're equal, it's okay. If it isn't, then it gets upset, right? So that's probably the simplest possible thing that we can do inside of this thing. And if we go off and just go do RBX, test under Bacon RB, that goes off, runs, and it says, you know, knows how to add, right? So those are the things that that certainly Ruby is very good at doing. Now, you can do some slightly more sophisticated things inside of this. So let's say, you know, it knows how to divide. We can do something like that, right? And we can certainly do things like this, right? Or because these things are integers, right? We'd expect something like that to work as well. right? But what about, the canonical example when we're doing math, right? Which is it throws an exception, right, when dividing by 0. Right, so we can certainly go off and create a little lambda expression, as it turns out here. Put the thing that we want to capture inside of here, dot should raise a 0 division error. Oops, I gotta get the. Right? So you can write these tests in a very concise and a very clear manner, right? So you're reading everything from left to right. It feels a lot better than the kind of Yoda-esque assert equal style things that more traditional unit testing frameworks have. So we come back and we can run this thing. We should see that all three of those things wind up passing, right? So that's what we can do with these kinds of testing things, and that's effectively sort of like a simple DSL for describing these things. The Ruby community has gone kind of wacky with these things, so there's far more complicated DSLs for doing these kinds of things, for doing storyboards and that kind of stuff. There's, in fact, as it turns out, got to show you this. You guys probably all got a copy of this, right, inside of your bag. And on page 98, Ben Hall wrote an article on .interop where he essentially talks about those other testing frameworks that can be used from within Iron Ruby. It's an awesome article. Okay, so we've got that. Now let's take a look at this stuff in the context of Silverlight. So what I wanted to do was show you a simple Silverlight application. The application is, let me kill some of this stuff here. There we go. Let's run. It's a spreadsheet, right? So, it's not a particularly smart spreadsheet, so don't expect it to do much. It was what I wrote on the plane. So you can put numbers in it. You can put little expressions like, A1 plus 2 and, all that kind of stuff, right? So it's a spreadsheet like you might expect a spreadsheet to behave. Now, how would you go about testing something like this, right? The spreadsheet itself was implemented in C#, right? It's a Silverlight 3 app. And as it turns out, through some interesting, awesome hacking that Jimmy Chimenti on my team did, if you go back to that URL and you append test to the end of that thing, right? So just kind of, zooming in there, we're just going to go off and add test to the end of that URL. What we'll see is, when this page refreshes, that nothing happens. Oh, yes. There it goes. It was just slow. Okay. That a whole bunch of awesomeness just happened. So what we have here is, at the bottom, we have a Ruby console that's come to life alongside of the Silverlight application that sits at the top here. Right? So this is a Ruby console. You can type things. You can go phi.times, right? Puts, John is great. All those kind of fun things that you do at stores. So that's a console. But that console was created within the context of your C# application, right? That's running up there at the top, right? So there was a little global variable that I, wound up squirreling away earlier, right? Which is called model, right? And the application itself is written in the model view model style, model view model style pattern that a lot of folks in WPF land like. And so that model there is pointing or poking at the model of the spreadsheet itself. Right? So there's a couple of operations that we can go off and do in there. So there is a set under cell method. And I can say, hey, I want to call set under cell, I want to set cell A1 to the value 2. Right? So you can see that I've done that, but you can also see that the 2 has appeared up here in the spreadsheet as well. Right? So I'm interactively poking at the spreadsheet to see what happens. Right? You can go model.set under cell A2 equals A1 plus 2, right? So I can go off and do those kinds of formulas and calculations and poke values at the spreadsheet programmatically, right? And see the results immediately appear back out, on the screen. Right? So that's pretty cool, right? Because there's an awful lot of things that we can do. This isn't how you would write your unit tests, but this would be a great way for you to go off and write your acceptance tests, right? For the different features that you're building inside of your Silverlight apps. right? So it's always nice to have this ability to kind of reach back in to see what's going on. So how does this work, right? So let's spend a little bit of time kind of poking under the covers of this application so we can see exactly how we wound up injecting a Ruby console into the middle of this application. So the first thing we're going to go off and look at is app.xaml.cs. So the first thing here is we're looking to see whether or not we have test as part of our query string, right? So we see test. We're going to go off and do this other thing. We're going to grab and download a file called eggs.zap. Right, you guys get the joke yet? There's bacon and there's eggs. So we're going to grab the eggs.zap file. The eggs.zap file contains everything that you need to test the app. Now remember that the app itself was just a C# application, right? So it didn't need anything else, right? What we need certainly for Ruby is a number of different things. So what I thought I'd show you next is let's take a peek inside of eggs.zap to see what's in there. So cd spreadsheet.web, cd client bin, and let's copy this and turn this into eggs.zip so we can actually look inside of eggs.zip. And if we look inside here, we can see that we have a whole bunch of assemblies in there, right? So we have Python. This was like the whole enchilada, testing thing. So we have both Python and Ruby as well as a DLR assembly sitting in there. Compress this thing is roughly 2 megs, right? You can get this thing down to maybe about 1.4 meg-ish. If you cut out the Python stuff, right? If all you wanted was Ruby. But the nice thing is here, you can write your things in Python, you can write them in Ruby, you can do a bunch of interesting things there. Inside of that eggs directory here is the actual, there's a couple of interesting things, but this is where the bacon library comes down as well. Right? So all of those things wind up residing and living inside of that single zap file, which gets downloaded in one shot. Okay, so then what happens after we've downloaded that file? So eggs.zap comes down. We'll follow here. We'll go down here to this method. So when the read is completed, you'll see that the first thing we do is we go off and we grab eggs.dll out of the resource stream inside of the zap. And then we do this thing where we go off and reflectively invoke a static method called start on the eggs class inside of this thing, right? So we're just going to dynamically go off and load eggs.cs. Now, let me go back to dev eggs source this file. Now, once we're inside of here, this is that start method that we went off and invoked. You'll notice here that there's a couple other things that I kind of glossed over above, but it's expecting a set of tests to come down. Tests are the names of the streams that it's going to go off and pull in that contain the individual test files. As it turns out now, inside of Silverlight's apps, you can't actually just reflectively walk over this stuff to find out what's inside of there. Or if you guys over there know how I can do that, I would love to, right? So, the guy up that packages this thing has to understand the kinds of files that you're expecting to see. So what we have there is we have this list of tests. We go off and we initialize the DLR. Now, we're going to see this thing in a number of different places. Oh, yeah. Hold on a second here. A lot of this stuff here is where we go off and create an instance of a new script runtime, which is a DLR thing, right? The script runtime will allow us to create the runtime that we need to initialize our engine, so a little bit further on down inside the code. The key things that we're doing here is we're creating an engine, and we're also creating a scope object. The scope object is what is going to allow us to persist variables across invocations, right? Because we're going to want to have a REPL after all, right? So each execution of the REPL has to be executed against a scope, so we need to squirrel off that scope somewhere, and that's what that second thing is there below. So now that we've got that thing in there, we do a little bit more stuff here where we I'm getting over a cold, so this is it's a miracle I've been able to talk this long without coughing. So I have eggs.rb there, which is the file that contains the kind of bootstrapping code for bacon. And down here at the bottom, you'll see that there are a couple of things here that you're going to use quite often if you wind up hosting the DLR in your applications. And that is, from the outside, you've got some set of objects, right? And those objects you're going to want to poke into the environment of your script. Right? So here we're setting a couple of global variables called engine and test under lists. And those things are used by eggs.rb to do its little magical invocation dance to get things to get up and running. Right, so that's all it is, right? It's really, all we're doing is from C#, creating a script runtime and a script engine, in this case for Ruby. Those hosting interfaces are the same regardless, so the code virtually doesn't change at all. If you want to go off and create an instance of Python, for example, a Python engine as opposed to a Ruby engine. In the second part of my talk, we'll take a look at what it's like to host Python inside of the spreadsheet. And then once we're in there, it just goes off and does the rest of the stuff, and there's just a bunch of details, after that, right? But conceptually, that's all we're doing. We load the eggs.zap file, eggs.zap bootstraps the stuff that's required to go off and run the tests. Now, this is the file that, it's configured to go off and run. Right, so there was a little bit of stuff that happened beforehand. So certainly there is, the same kind of stuff that we saw earlier with our spreadsheet. Sorry, when we're just looking at the simple, math stuff that we can do with eggs. But what I want to show you here is, let's, instead of watching me type a bunch of code, let's go off and get the answer. And spreadsheet, no. Yeah, this guy. Is this going to work? Yes, it will. So I'm doing something really dangerous here. And but how could that be dangerous? You're copying and pasting text, right, into another file. This turns out to be very dangerous. Let me explain why. So it's okay here, right, because I had this file created already, and this file successfully ran in Ruby at least once, right? So what does that mean? We know what the encoding of the file is. Iron Ruby can only eat ANSI encoded files, right? It's a long story, right? But unfortunately, that's just the way the language is designed. So if you create a new file in Visual Studio, the default encoding is not ANSI, right? So if you do that, you'll get some really bizarre error that says variable I is not defined, because it gets really confused, right, with the bomb that sits at the start, right? So, so be very careful if you're creating new files in Visual Studio and copying stuff in. But because this was an existing file, this will just work. So what this does is just a bunch of things that you might, expect us to do. It's, you can read the test as well as I can. And if we come back to the app and we can run this guy. Test. So it goes off and runs the tests. Right, you'll see that, we ran through 5 specifications, 17 requirements with 0 failures and errors. Right? So again, it's really nice to have this kind of relatively quick feedback about how the tests are progressing, but you're testing it inside of the environment where you're actually going to be running the code at the end. Cool. So that's the first little part where we're going to kind of look at the testing angle. And I think that there's a fair amount of value that people can have here, right? Like certainly if you've been itching to go off and use Ruby, this is a fairly innocuous way for you to go off and introduce Ruby into an existing application, right? By kind of bringing it in from the edges and writing your test framework using that. The second thing is actually, I would think, perhaps even more useful, right? And that is, let's take an existing application and extend that application using a scripting language. Right, so for this case, we'll use our other language. We'll use Python to go off and write the extensions. And for a spreadsheet, I think the pretty obvious thing is, spreadsheets have all those at functions. Right? So let's go off and make it so you can write your at functions inside of Python. Right? So now you've got this nice ability whereby not only could you potentially write your tests using this thing, right, but you now have the ability to empower your users to do something that they would otherwise need a build environment for your application to do. So that's what the second tab here is all about. So there is, there's some other code that I haven't shown you yet, but what happens here is this is where we can go off and type our code, and this is just Python code. That code was actually downloaded from the MVC project that backs this whole thing. I haven't wired this thing up yet, right? So what I'll show you next is, how to go off and make that thing actually work. So just like I showed you before, but I'll show you a little bit slower this time. What we're going to do is we're going to go off and host IronPython inside of this application. Same two concepts that we need. We need a script engine. The engine is going to allow us to go off and send strings to go off and execute against. And the second part is we're going to need one of those scopes, right? Because we're going to be sending these strings in every time we go off and evaluate the expression. So this thing essentially lives in the same namespace as we had before. And public class extensions is the type that I need for this thing. And there's these two variables that I need. So script engine, and we can use that awesome control dot feature in Visual Studio. Easily my favorite feature of all time in Visual Studio. Private static script scope. That's the other guy that I need. I'm going to save off a couple of those guys. And really what I want is I want a static method which executes some code that I pass in as a string to this guy. And so we just have to do some initialization, right? If engine is null, right, we'll go engine is equal to Python dot create engine. So I'm going to go off and create my Python script engine. That's just a shortcut. There's a bazillion different parameters you can pass to this, but that sets you up with a reasonable set of default parameters. And from the engine, we can go off and grab the runtime, and we can create a, we can create a scope off of that guy as well. Okay? So once we have those, we can simply go off and go engine.execute the code that we passed in against the scope that we're keeping around. Oops, in this case here. Okay? So that's essentially the, 10 lines of code that you would otherwise have to write to go off and host arbitrary DLR languages inside of your application. Now, that's the easy part, right? We need to plumb it in a couple other places, and we'll see that in a minute. But this is the part that I think is particularly interesting. And this is the part that part of my, begging for help from you guys is, for those of you guys that run open source projects, which can benefit from adding scripting to it, right? So I certainly talked to a bunch of folks here, about things like, Twitter client, right? Could be one of the obvious things where having some more intelligent filtering, right, might be a useful thing for, the Twitter addicts of the world. But you can go off and write that stuff in Python scripts, right, that can execute on the client. And that's a fairly trivial thing to go off and build. But so there's this benefit that you can get immediately, right, by simply allowing people to extend your application without having to figure out how to go off and check in sources into your repository and all that stuff. But there's another thing. And this came out of a set of conversations that I had with Rick Brewster, who is the guy that created Paint.net. And when I pitched the idea to him, he said, yeah, that'd be a great idea, right? But what he realized was that the internals of Paint.net were totally unsuited to doing that set of user scripting operations, right? So he'd have to go through some massive refactoring job, across his code base in order to make it, more easy for folks to go off and script the objects that are inside of it. And that makes sense, right? So my belief here is that what happens when you introduce scripting to your users, you get a number of benefits, right? You get this testing benefit that comes back out, right? Because that refactoring is going to drive your software to be designed better to facilitate the testing, which will also be in such a way that it's going to allow you to facilitate people being able to script the behaviors of the objects inside as well, right? So I think that is going to wind up producing better software in the end coming out of this thing, and it's a twofold thing. You get this engineering benefit from having the better software, and you get the end user benefit from that as well. So for folks that have existing open source projects, adding scripting to your thing, I think, is going to force you down this path of refactoring, right? Because you're just going to cringe when you have to explain to your users how to script the things that you've created inside of this thing, right? So I think that that's ultimately going to make for better software. So let's finish this thing off and see the kinds of things that might fall out of this. So let's go back out here to here. And let's go off and compile to make sure that actually compiles. So you can see I'm going to cheat here. So there's a couple of places here. When I come across a token where I recognize that it's a function, what I'm going to do here is, a bunch of boring parsing code is in here. But in the tokenizer, I'm going to get the current value, grab its string. I'm going to assume the rest of the thing is what it is, and pass that to the script engine to go off and execute, right? So at function, at foo, and the rest of the function gets thrown into Python. Python evaluates the result, and we return the result to the caller in this case, right? So this is at the heart of the calc engine inside of this guy here. A couple other things. You don't need that. Where's the other place? Yeah. So here, we're also going to load. So this is part of the code that comes in from the server. The server side, we actually call into MVC and get it to load. We use the MVC code on the server just to persist the code in the spreadsheet. So we load that. So when we load it, we execute it and display it inside the box at the same time. Thinking. Oops, it's a focus thing. There it goes. So now that this comes back here, this thing has actually executed and is live now. So I should be able to go, here's type some number here, at total, 1, 2, 3, 4, 5, right? And that goes off and it calls the Python code on the other side. We can certainly at runtime, so this is kind of a nice thing that we can do here, right? Is we can also allow users to define arbitrary methods themselves, right? So we can square x and y, let's say, right? So we can return x, or not square, let's just square this, right? We can do something like that. What did I just do? Right, so I can do that. I can execute it using my magic keystroke, which is Control Enter. And I can go SQR, right, to, and of course we crash. Oh, yeah, I've seen this before. Hold on a second. Square of this. Yeah. Go away. See, this is a real demo. This is really code. This is live code. It's Python. I have to make sure that I hit that carriage return there. I hate you. Oh, no, I know why. Stop. Let me call it a different name. Hitting wrong keys. Okay, there we go. Let's try this one more time. Oh, what on earth is this? So ThinkPads have these awesome keys right next to the up key, which takes you back in the browser. So come back here. Let's define the method. Let's do this one here. For arg in args, sum times equals arg, return sum. We'll do that. We'll come back to the worksheet here and go at product 2, 3, 4. Oh, I hate you. Product is not defined. What do you mean it's not defined? Oh, wait. I know this. Okay, hold on. I'm going to fix this. There's one more thing that I forgot to uncomment. The thing that actually executes. There we go. All right, now this will work. I promise. I knew there were 3 things that I had to do there too. All right, so let's come here. Def product, args, right? This damn case, this tabbing, spacing thing drives me crazy. And it has to be right as well. Otherwise, it gets really angry at you. That's really product, but anyways. What do you mean it's not defined? Yeah, go away. We'll come back here. Aha! See, that worked now. Okay, let's make sure that's actually real. It's that I have to make sure that I hit the enter key. Thank you. This is why you should never have a Ruby guy do Python demos, okay? All right, so, but that's kind of funky, right? In the sense that, you know, you have this ability to allow people to, you know, kind of build out a program. I don't know if you guys have seen a really innovative spreadsheet out there called Resolver, or Resolver 1. So Resolver 1 is a spreadsheet that is kind of built in this, with this idea. Because you know that in traditional spreadsheets, when you have all your formulas, they're just kind of hidden inside of all the cells, right? You can't actually see the relationships between the different formulas that you have inside of there. So what Resolver 1 does is it actually writes a Python program, right, based on what you enter inside of the spreadsheet. Right, so it's one of the big kind of commercial successes for IronPython, because not only does the Resolver 1 spreadsheet generate a Python program as you enter things in the spreadsheet view, but it's also itself written in IronPython. So, and it's used by a lot of folks that are really interested in, you know, what happens when you fall off the end of what you can do or conceptually keep inside your head in an Excel spreadsheet, and you want some more power, right? So that's a really nice thing about what Resolver 1 can do. So there's lots of kind of interesting things that you can do with these languages once you get down here. Now, this is just a little toy thing I kind of, you know, built on the plane. You could, you know, certainly extend this in a lot of different interesting ways as well, right? So I've got a little, you know, simple little tokenizer thing that tokenizes this stuff. So you can imagine the next step that you can do here is those expressions that we generate there, we can go off and generate DLR trees for all of those expressions, right? And actually compile those things and get those to run as well. So, you know, there's a lot of interesting things that I'm going to probably continue hacking on the sample in my spare time because it's just kind of a fun thing to build. Never built a spreadsheet before, right? So I always thought it'd be kind of a fun thing to work on. But anyways, those are the kind of, you know, ideas and concepts that I wanted to get across with these things, with these two demos here. So let's come back here. So we talked about the scripting part. The view part is rather interesting. So the third part of this thing is, you know, I didn't really want to do that. So this is some code that Phil sent me, which I had to fix. Phil, if you're watching or hearing this, I had to fix your sample that you sent me. But this is an example of Iron Ruby running inside of the server-side code, right? So this is ASP.NVC integrated in with Iron Ruby as well. So, you know, this is, you know, kind of like a typical kind of MVC demo. There's some stuff in a database. I can click on categories, and it shows me things inside of categories. I can come in here, and I can edit things, and stuff happens. And, right, so the kind of typical MVC thing. Now, this is a case where you might be saying, well, you know, what should we really be doing in Ruby, and what should we be doing in C#, right? Because we certainly have the ability to go back and forth both ways inside of this as well. So in a lot of ways, the low-hanging fruit here is to go after the views, right? The views are generally very kind of template-y kind of code, and it's stuff that dynamic languages are rather good at doing. So let's kind of take a look at some of the stuff that we have here. So let's take a look at the list stuff here. So when you look at this templating thing, what we're actually executing inside of here is Ruby code, right? So viewData.products.each, product, blah, 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 blah. Inside of there, we actually have a block. Inside of that block, there's an opening curly brace and a closing curly brace, which is way down there. You can see that, you know, Visual Studio really does not understand, you know, the syntax of this at all, right? But that's OK. So between there and up here, it's going to execute in a loop, and it's simply go through and iterate over the loop and get that thing to run as well. Right? So the ASP.MVC team is kind of in their spare time being kind of maintaining this sample rolling forward with each release of MVC. They've been pretty busy shipping 1.0 here. But after this, they've got some time to actually make this something real that will ship sometime down the road. Right? So I think this is a pretty cool thing for us to be able to show, you know, things we can do on the server as well as on the client. The application I was showing you earlier, this guy here, is even a bit more ambitious. It's not as interesting because it doesn't do very much, right? But But if you look at the controllers here, you see here that whereas in this application, the MVC demo, you can see that the controllers here are all written in C#, right? In the spreadsheet case, the controllers were all written inside of Iron Ruby, right? So you can see here that we've got a script controller derives from controller, implements, the actions that are going to run there. So we have this nice ability, to mesh in with existing .NET frameworks up on the server as well, right? So this was the result of a lot of our .NET interop work and our push to get here to MIX. All right, so we've got MVC, we've got views. So we get to talk about this. This is some of the fun stuff. So there's three things, right? So certainly the big feature was the out-of-browser feature, right? I'll show you that first because that's the easiest thing to show you. After that, we have transparent extensions, and I'll show how we've packaged up our existing stuff and we've put them up on our, we've put them somewhere on the internet for the time being. I'll show you where it is in a second. But down the road, when we get to a release of this thing, this will be sitting inside the Microsoft Content Distribution Network as well. So the nice thing is that to get Iron Ruby plus the DLR onto your machine, depending on whose compression algorithm we ultimately wind up using to compress this thing with, it's somewhere in the neighborhood of about another 1.5 meg, right? So it'd be nice to have that downloaded once, cached on your machine so that you don't have to pay that 1.5 meg download cost each and every time somebody hits your application. We'll see some of the cool things we can sign because we have the magic key at Microsoft, and we'll talk about some of our more recent work in fixing our interpreter as well. So let's look at the first part. So the out-of-box thing, this is my spreadsheet. If I run this, you guys have probably seen this demo a million times. This is the problem when you're at the end of the conference, right? So this is no longer an impressive demo for you guys. It still impressed me, right, when I was, doing it last night. But this thing is now installed locally on my machine. Same thing we had here, right, with the shortcut on the desktop, so I can relaunch it, all that kind of good stuff, and it just comes back. So that's kind of a nice thing to have here. One of the caveats, though, if you want to go off and get this application, it's not a big deal, right, because it should only be downloaded once because you're going to install this thing to run on your machine, is that if you had things configured to use the next feature I'm going to show you, which is this transparent extensions feature, you're going to have to change the config, right? This install and run locally thing requires everything to live inside of a single zap, right? Okay, that's an important point. And then that's the thing that gets installed locally on your machine, right? So we have that thing there. So let's do the magic incantations to make this guy here run. Aha, it's a different color. No, wrong project there. Okay. So this is the app manifest file that you need. So this is the first place that you're going to have to start, right? So if you want to go off and configure Iron Ruby to go off to configure. So what we've done, hold on, slide is better. So there are essentially these three packages that our team is going to produce, right? One is the Microsoft.scripting package, and that's the DLR pieces. We'll have one for each of Ruby and Python as well, right? So the idea here is you only need to reference the thing that you're actually going to use in your machine, and so we're going to factor these things out into the smallest possible set of packages. So back to the app manifest that we have here, what we want to do is uncomment the one here that will go off and download Microsoft.scripting. So that's the core stuff that we need to go off and get and run the DLR. And this is the Python thing, so oops. We're also going to need to uncomment the Python modules, right? Because remember, the spreadsheet has a dependency on Python for all the extension methods. So we uncomment those two things, and then we have to do a little bit of build GUI, gunky magic stuff. So the build GUI, gunky magic stuff here is do that. No, that's, yeah, turn that on. And go to your references, grab these guys here, go to properties, and tell it not to copy these things locally, right? So what we're doing is we're essentially excluding everything out of the zap at this point. If I do a rebuild of this guy here, and now let me do the little incantation here so you can see the effects of what this, I should have shown you the before. Oh, I always forget that. Okay. I need to make this the default browser. Yes. Okay. So now that that guy's the default browser, and that's the wrong project. Where is the other guy? Did I shut him down? Oh, why did I do that? That's, oh, he's the wrong color, that's why. Okay. So let's run this guy. He's going to launch now inside of Firefox. And the reason why I'm launching inside of Firefox is not just to show that it actually works in Firefox, but it's because we got Firebug inside of Firefox. And Firebug's got this awesome feature which shows you timings and sizes and all that other fun stuff, right? So, so in this case here, you can see all of the stuff that happened here. Now, this might appall you at the same time, but anyways, we'll leave that as it may. The first thing you see here is a I didn't mean to click you. So the first thing here is we're going up to the FW link stuff at Microsoft, the redirect mechanism inside of Microsoft. So for each one of these guys, we're doing that. And it's redirecting us to go off and download some things. So here are some of the extensions we have here, some more there, the component model stuff. And then we see some of these interesting things like jimmy.shimenti.com, right? JFLAM demo. So Jimmy hacked up, because we're not done, right? So we're not going to package these things up for real yet and sign them and go through that whole thing, right? So for the purposes of this demo, what the Microsoft.com thing does is it redirects somewhere, right, to the CDN to actually download the SLVX files that you're going to need to execute on your machine. So in this case here, some of the things here, like the Microsoft scripting and the R and Python SLVX are both coming up off of Jimmy's website in this case, right? But down the road when we're done, when we're at a point where we're going to go 1.0, we're going to sign those assemblies, we're going to post those things up on the Microsoft CDN, right? So you should get very good download times with this. Now that's of course the first time that we grab this set of things. We come back here and we refresh this guy. And we bring back up Firebug. We should see here that, lo and behold, it's now only 112 kilobytes of stuff that got downloaded instead of the 3 megabytes that came down, that first time, right? So it's a one-time download of this thing down to your machine, gets cached, and then afterwards it's the min set of things that you need to actually run your application, right? So that's a heck of a lot better than it was before. Now, some of the ugliness is some of the things of, well, that's random goo here, but there's an awful lot of requests that are happening here, right? So certainly the amount of additional latency there is something we're not really happy about. We're thinking about what we could potentially do to fix that, right? But certainly a lot of suggestions would be welcome, and especially complaints about that would be welcome, right? Because you know how things work in Microsoft, right? The squeaky wheel gets the oil, right? So that mechanism there, while it's good, the more of these kinds of things and the more you factor it out, the more latency you're going to ultimately introduce into your equation. So it's really all about that time to last byte kind of experience in here that we really need to get right. So that's the second thing. Let's go back to here. So that's the transparent extension stuff. Now signing. For assemblies that we bless at Microsoft, they get signed with a special key. And when we sign these assemblies with these keys, those assemblies get to load in a domain-neutral fashion, right? And that turns out to be very good in the cases of platform components, right? If these platform components are going to be used, let's say the user goes to one Silverlight application and then surfs to another one and then to another one, right? What would otherwise happen if the code wasn't loaded in a domain-neutral fashion is that you would have to go off and rejit all that stuff because you're throwing away the app domain when you're crossing the security boundary, right, to go to the next page. You got to rejit, and you got to rejit, and you got to rejit. So if you have a lot of stuff that you need to jit, especially if you're a scripting language, right, where you need an additional, when it's uncompressed, 3 meg-ish in that ballpark worth of assemblies that you need to go off and jit some reasonable percentage of them in order to run stuff. you're in this really kind of ugly position where you're going to be introducing a lot more latency. So because our stuff's going to be signed with a key, we load domain neutral. We get JITted the first time, obviously, but then on subsequent requests, we don't need to be JITted again. Right? So that gives us much better performance characteristics. Back to that time to first pixel appearing on the screen kind of experience there. Now yours. Excuse me. I'm almost going to make it through this talk. All right. So the interpreter piece. About 3 or 4 weeks ago, Jim Huguenin went off and did some hacking, and he built an improved DLR interpreter. The reason why we need an interpreter, DLR was always built from the ground up as a compiler. And in certain scenarios, and especially in the scenarios where you're running unit testing code, which is essentially a lot of straight line execution, right? You're going to compile a whole bunch of code to run it exactly once. The overhead in actually going off and compiling all that code swamps any possible performance gains that you're going to get from compiling that stuff. So we've been doing very poorly on our unit tests. But certainly now that we've got this new interpreter, which interprets DLR trees, it's a fairly sophisticated interpreter in some ways and not so sophisticated in other ways. It's a stack list. It's a very Forth-like interpreter that was checked in. But what's interesting is it's still walking our trees, right? So we still have our trees. We're walking our trees. And that interpreter will run the PyStone benchmark at half the speed of the CPython interpreter, which is pretty damn good, right, for a tree walking interpreter. We can make that thing go faster, but we've kind of gotten it fast enough to get to where we want right now. But that's something to take a look at. Now that we've got this interpreter in there, that means all of the languages are going to be able to come online with and use the DLR interpreter. We're probably, I would say, I don't think the check-in has gone in yet, right? But we're probably about a week away from getting Ruby to use the new DLR interpreter fully. And so when that happens, we're also going to be able to publish some new numbers about how well we run unit tests, right? Because that's really one place where we really fall over and perform very poorly. This is also going to have the nice benefit for Silverlight applications as well. We also have an adaptive compilation algorithm. It's a very stupid algorithm in there today. All it does is it counts to 3, right? So the third time, it's going to go off and actually trigger the full compilation pass against the thing that you're trying to invoke. But we'll see how that works, and we'll tune that as required down the road, right? There's certainly a lot of things we can do with adaptive compilation later. So you should get the nice benefit of very nice startup time, right? And I think that certainly in web-based applications, you're going to care a heck of a lot more about how fast the app starts up as opposed to what the ultimate throughput of it is, even if there's a delay before it kicks in a high speed. So here comes the begging part of the talk. So certainly on the Ruby side of the house, we take contributions into our libraries. We're in this big push to try and get to 1.0. We did a number of things recently to make it easier for people on the outside to collaborate with us. For a lot of reasons, the reason why it's hard to collaborate with us being Microsoft, is the fact that our testing infrastructure and our source control system is married to our domain, right? And that's just the way that stuff works. And so because of that, we've always had to maintain 2 repositories, right? One for external folks, one for internal folks, and we sync these 2 things. And that's painful, right? But we deal with the cost of doing that. What we've recently done is we've moved over to GitHub on the outside world. And what GitHub really buys us is this ability to delegate a lot of the busy work, I hate to say it, right? But certainly the work of doing things like code reviews and other things that used to be done by us to folks on the outside, right? And they can integrate things in the external repository, and we can pull those things in, back in and do the 2-way integration piece that we need to do. So we've got people to do that part, but we can delegate more work in the actual maintenance of libraries and that kind of work, to the outside. And that's greatly streamlined our workflow. People can go off and fork our external repo, go off and hack on the stuff they want, pull things from our external thing whenever they want. Once they get that stabilized, send us a pull request, we'll pull from them and integrate it back into our trees. It's a much, much, much nicer workflow. So if you're familiar with Git already, it makes it much easier for folks to do this. Now, the thing that really makes this work is GitHub. Right? Because Git itself is a real bear to set up if you ever tried to set up Git yourself. So GitHub is a web service for Git, which acts as sort of like the central repository out there, even though it's a distributed version control system. So folks can essentially sync up to that thing, and we can pull that thing back in. So it's a really, really nice workflow. And I think it's about as easy as we can make it, given the fact that we are still married to our internal testing infrastructure and all the other things that we're building on top of at the same time. Had to get this guy in here. So the interesting thing about the kinds of things I've been showing you here is really kind of mixing different cultures, right? The statically typed culture and the dynamically typed culture at the same time. And I think that there's going to be a lot of interesting things that people are going to be able to build that come out of this intersection of these two things. Because I certainly haven't seen an awful lot of applications. Like, there's some really popular applications that do this. World of Warcraft is probably the best one that I can think of off the top of my head, where all of the end user scripting in WoW is being done is done in Lua, right? So folks can go off and build these things without obviously requiring and there's actually a marketplace and a whole community of people that go off and build these things. So I think that there's some really interesting things that can happen there. Now, if you have success in this, I can build extensions part of the story. You can perhaps get some success in the, what if I wanted to build an actual application out of a dynamic language? And perhaps the best example of that, interestingly enough, it's also a Lua example, is what happened with Adobe Lightroom. 60% of the lines of code in Adobe Lightroom are written in Lua. The other 40% are C and assembly language, right? Depending on the things that they wanted to do. So that's a very large commercial application, that they certainly benefit, because it had this additional characteristic that they needed it to be cross-platform as well, right? Because both Mac and Windows are very important to that customer base at Adobe. So there's been a lot of things written up and interviews with some of the folks that were on that team that wound up creating this interesting app. So I think that certainly there's a lot of opportunities to kind of marry these two worlds without being dogmatic and saying, I need to go off and build everything in just, my dynamic language or everything just in my static language. So to kind of recap, we just talked about some of the things. Remember, we're trying to get to 1.0. I implore anyone out there that wants to help us certainly on the Ruby side of the house to get to a 1.0 release by July. We walked through those scenarios. Test, I think, is the easiest one. Right? So certainly going off and playing with this thing. Those demos, by the way, are going to go live sometime right after my talk. Jimmy's got his finger on the button back at the ranch. So those things are going to go live probably right after this talk. And the scripting thing is a little bit more work. You saw that it's a trivial amount of work to add the code to embed the scripting runtime into your application. The hard work is what you might need to do to your application to make it so that people can actually script it well. Some of the MVC stuff, some early work there, but I think that there's some really interesting opportunities there, especially around the views and potentially on the controllers. The controllers are even more interesting. That's one thing that I didn't really mention there. Because the controller's job is really kind of dealing between the model and the view. There's really no reason why your controller needs to run on the server, right? And if you can build your controller and it's written in Ruby, right? And you can run Ruby on the client as well, right? You have this ability to put, to essentially use attributes essentially on your methods to say, I want this action to be a client action and this other action to be a server action, or I want this action to run in both places. Right, so a lot of those things, you now have the ability to write it once, but have this benefit of being able to execute the code in multiple places as well. So I think there's a very interesting place for folks to explore. We haven't had the cycles to explore that part yet, but I think that there's some interesting work that can be done to get controllers to run both on the client as well as on the server. Talked about the optimizations. Remember that the kind of key things that we have are with the Silverlight transparent extensions that gives us this nicer download thing that we saw there. The offline applications obviously allow us to cache the whole thing on the client, which is a good thing. Our domain neutral code, when we sign all of this stuff, so at least the stuff that we're producing with Ruby and Python and the DLR will be signed using the keys so that you don't wind up rejitting every single time you go to another page. And then, what was the final thing? There's one other thing. And of course, I'm begging for help. So that pretty well gets me to the end of the talk. I've got 10 minutes left. We've got such a small group here. Let's open it up to questions and talk. What would you like to see us do? So you wanted to see the part where I was showing Ruby in the MVC app. So it was inside of this, this template here. Right, so all of the code there, like, because it's really just dotting into stuff, right? So it could look like almost any other template language that you can imagine, right? But that's all Ruby code executing inside of it. The key thing is viewData.products.each with the curly brace and the goalposts. So the view is being rendered here inside of Ruby. And Ruby's very good at doing these kinds of things, these kinds of template engines. Oh, view data comes in from over here. So we come back here to the products controller, right? We set view data here, right? So there is an implicit self, right? That here, let me go back here. So view data here, there, in front of here, there's an implicit self here, right? Now, one of the interesting things about Ruby the language is we can have dynamic scoping as well. So I can redefine what self means in different contexts, which is kind of an easy and frightening feature to some people. But in things like this, for templating languages, it's really nice, right? Because otherwise, I would have had to poke in something, right? And it would be like, x dot, that thing, right, in order to get the reference to it, or some global variable or some other thing. So what we're doing here is we're essentially evaling this thing within this context, right? The trick in Ruby is just look up the method called instance eval is all we're doing here. We're instance evaling against an instance, and that instance happens to be the thing that contains view data. More questions? Come on. What other things? Comments, criticisms? What are we doing wrong? What are we doing right? Sorry, the question was, why do we drop the managed JavaScript? Oh, so you want to ask the controversial questions here. So what happened was that was always kind of intended as a thing to vet the DLR, right? That project was really, there was a bunch of guys that we had that worked in IDC that wanted to work on JavaScript, right? And we had some guys over here that wanted to work on JavaScript as well. And they were interested in it at that time. And they went off and built this prototype. And for various reasons, that prototype didn't work out all that well, right? So, and because of other random things, those guys had to do other jobs. And so that ever basically got shut down. So, but would you like to see a managed JavaScript implementation?
Yeah, well, I don't know anything about
So you, okay. And you would want to use the JavaScript to go off, and simply because of where you're coming from, right? So you'd like a managed JavaScript to talk to the .NET libraries. Yeah. And not, so Silverlight 1.1 doesn't cut it for you?
No, I realize you can go through the DOM.
Yeah.
Which is fine. It's kind of hard to really grasp usefulness of this Ruby stuff when saying Silverlight apps, you can do all that JavaScript.
Sure. But the thing is so I guess the comment really was, why should I use this Ruby and Python stuff, when I can already do what appears to be almost all of these things inside of JavaScript? Is that more or less the comment? So the thing is that different languages influence your thinking in different ways, right? So whereas JavaScript is certainly a fine language, right, if you use it well. This interesting thing that we can do with these internal domain-specific languages, right, to kind of use a popular term, is something that's particularly powerful inside of Ruby, right? And that influences and changes the way people think about doing things. That whole behavior-driven design kind of movement came a lot out of the fact that the folks that were very passionate about that stuff came out of the Ruby community because of this aesthetic, right? You saw that those tests read left to right, right? We had this interesting way. And it's a small set of features in the language that actually make that possible. Very simple things like, parens are optional, right, on method calls. Make it so that things that would otherwise look like a method call look more like it's a statement in the language, right? So people can put static methods on classes, for example, right, that are used to initialize different parameters to do a lot of declarative programming. So that's really what attracts people to Ruby. You know, and so that's some of the motivation really to try and get folks to look at it. And I think it's well worth your time, right? You know, to certainly take a look at the examples. You don't necessarily have to spend a lot of time. Like one of the best places for you to go off and spend a very quick 15 minutes is to go to tryruby.hobix.com, which is the realm of this awesome, crazy person in the Ruby community called Why the Lucky Stiff. And if you type help here, right, you'll notice down here that it's kind of reading what I'm doing here and saying blah, blah, blah. And if I do the last thing at the bottom, it's, you know, and I say put my name in quotes like that, and it bounces. It teaches you Ruby, right, interactively. What he's doing is this kind of interesting, awesome hack where he actually executes all that on his server. Right? He's not running Ruby on the client in this case. But that's a real quick way of just kind of playing with the language, right, and, you know, and getting a nice introduction to it at the same time. So what we're doing now is we've got this list of things that we need to do, right, which we have because Ruby is really being done in a test-first style development process, right, because we have the tests out there. We fill in the tests that are missing as well, right, so we're contributing tests back to those folks as well. So certainly we have this site here. Hold on. So ironruby.info is our kind of current stat site, you know, which kind of shows what our progress is on different things and differences and how well we're doing. And I have arguments about what those numbers mean. So sometimes we run more tests than Ruby on Windows, and sometimes we run fewer tests than Ruby on Windows, right, in terms of this full set. So those percentages are sometimes debatable. But from here, you can kind of look back and run the test suite. So if you download the sources for Ruby, we have a wiki. If you just go off to ironruby.net, off our wiki, there's a bunch of stuff about how you can contribute, you know, how you run our test suite. You can run your test suite, and it's going to give you a nice report of methods that aren't implemented when it comes out. So that's really the burn down list of things that we have. The problem there is that list isn't prioritized. You know, this is, we fail on this method, right? But we don't know how important that method is. You know, so there's a fair amount of triaging just so that we can kind of set the order of the things that we need to do. When we were doing our push for Rails, what we did was we hacked up MRI's interpreter so that we would actually do runtime tracing. So we would actually output the execution traces. We knew all the methods it would call, right? And we would, you know, essentially do a little munging of that. So we get essentially a list of the things that we weren't running, right, when we ran these things side by side. And we also use those execution traces to verify that at the very least, right, we're calling the same sequence of methods in the same order between MRI and us. So we use that to make sure that we're getting the right answer at the end. So there's another open source project called rubyspec.org. And so these guys have a number of projects. So there's the Ruby specs themselves, and they also have a bunch of test running infrastructure for this as well. Right? So they're the central repository. These guys are all on GitHub as well. That's a centralized repository where all of the specs live, and so you can certainly go off and fix and contribute additional specs, because there's areas where there isn't great coverage, for example. Regular expressions is a great place that we definitely need more coverage in. Anything else? Yes? So the question was, can I build the same application in Ruby as in C#? It depends on how you define same, right? Like a lot of things. So what are you going to give up, right, is really the question, right? Because everything in life is all about trade-offs. You're not going to get the same straight line execution speed out of a pure Ruby application as you're going to get out of C#, right? That's a given. There's a cost to the power that you get. Now, could you build it more quickly in Ruby than in C#? Perhaps, right? You know, that's really one of the things that folks like to talk about, and you know, about the dynamic languages, is the ability for you to interactively build these things. When you're building these things, it's a very different kind of workflow that you go through than just the edit, compile, debug cycle that you go through in your IDE. Instead, you tend to build out your application inside of an interactive prompt, right, in a REPL. You'll do that stuff, and then you'll take the stuff that works and bring it back in, and that's an incredibly productive style of programming. Sure. Like, oh, it's telling me I'm out of time. So we have to cut this off, but I'd be happy to come on up and I'll answer your question in that. Okay? But thanks for coming and